Welcome to the Wonder with the Witte Podcast, coming to you live from the Live Lab.
The SWBC Live Lab, to be exact. Deep in the heart of San Antonio, Texas, my name is Abby Jax. I'm the Environmental Science Education Manager here at the Witte.
I'm Daemon Piña. I'm the Health and Wellness Education Manager here at the Witte Museum.
All right, awesome. Welcome to episode 3 of our series of the Power of Poison podcasts. Mm-hmm. So today, super excited, we're going to be talking about snakes. Snakes. I always feel like that's the most, like, of the venomous things in Texas, like, of all of the phobias to have, this is the biggest one. I mean, especially with even adults, even adult people, like, this is the biggest phobia that most people have, right?
Yes.
So, I don't know, after working with and being around snakes for a really long time at this point, they're super cool, and I feel like they're super...
demonized.
Yeah, like, not understood well.
Do you remember the first time you held a snake? That's
a question. I don't know.
So I hadn't held a snake until I started working here at the museum. I didn't. I grew up in the country, and I just, like you're saying, I assumed any snake I came into contact with out there was a rattlesnake.
Yeah, was a threat.
We were, 20 minutes from the nearest city. So
yeah,
if I get bit, that's at least
game
20 minutes.
Over, man.
Yeah, that's 20 minutes to get to any of the towns around us. So I just didn't. I had no, I didn't have anything against snakes, but I had no desire to handle snakes.
Yeah, like nothing scares people like a snake, especially one that they're not expecting. Like, take it from somebody who knows and has been handling snakes, and like even like little corn snakes, like little fun guys that you're just like, look at this guy, look how cool he is.
Yeah.
And someone comes up and doesn't know that you have one, panic immediately.
Yep.
So
it's really fast, that reaction.
It really is. And then there's no mediation of the reaction either. It's usually like screaming. So, but to start this off, I think we should have a countdown of how many times did I say this, right? So we're going to talk about the difference between poisonous and venomous.
Yes.
So for everybody listening, if you want to be smarter than your friends right now, we do not have any poisonous species of snake in Texas, right? Because poisonous, you have to touch it, you have to eat it for that to make you sick.
Okay.
Venomous, it has to bite you, it has to sting you. So we don't have any poisonous species, but we do have 4 overarching types of venomous snakes.
Okay.
So that's the big takeaway, right? Poisonous versus venomous. We have venomous snakes here. We do not have poisonous. So a little history lesson for you before we get started. In about 1933, the Witte Museum opened the Reptile Garden, which housed various venomous and non-venomous snakes, alligators, and assorted reptiles.
Yes.
So Dr. Dudley Jackson Sr. conducted research during this time. He created something called the Dudley Kit, which was manufactured by a San Antonio business called the FAAP Company. But essentially, during this time, the Witte Museum was like one of the forerunners in antivenom research.
That's crazy. I didn't know that.
Yeah. Right here at the Witte, we have a spot in history for developing antivenom.
That's so cool.
Super cool. So, all right. So let's launch immediately into snakes, right? So there are 4 overarching types of venomous snakes, right? We have rattlesnakes, we have copperheads, we have cottonmouths, and we have coral snakes.
Got it.
Okay, so let's talk a little bit about how envenomation actually happens with these species. So with all snake species that are venomous, they have a little venom gland that sits behind their jaws, right, which is where venom is stored. They have a little duct that connects the gland through the mouth into the fang, right? And then the fang is ultimately what delivers the venom into a bloodstream. And they also have a little compressor muscle that sits around the venom gland.
To squeeze it out?
So
Sick.
They bite, they squeeze the muscle, compresses the venom through the fang. But the really cool thing is that there are several different types of these things. There's not just one specific type for any venomous snake species. So as we talk about some of these species, talk about that a little more.
Yeah.
But to start off with, we're going to talk about our pit viper species that we have native here in Texas, and that's our rattlesnakes, copperheads, cottonmouths. So specifically, these guys are solenoglyphous. So in regards to their fangs, this is the structure that all of these animals have.
Okay.
These are considered the most advanced of the fang styles.
Okay.
And what that means is that these fangs are hinged. Yeah. So when a snake's mouth is closed, or when a pit viper's mouth is closed, the fangs are like tucked up on the roof of the mouth.
Okay, so they're like up, like.
Yeah, like
okay.
up here.
Yeah.
So when they go to open their mouth to inject venom, the fangs swing out.
Okay.
So the cool thing about them is that there's usually spares because these fangs are the longest, typically for most species. So they can have like 2 or 3 that sit up here.
Okay.
That swing, right? And they're injecting with a main fang, but if that fang happens to break because they are so long, then they have spares.
So gross.
Wild, though, right?
Yes.
So one of the most advanced systems of venom delivery.
Yeah, that's really cool. Do you know if one of them breaks, so then the one next to it takes its place, right?
Yes. Yeah.
Do they grow another one, or do they have a set
I don't know
number?
if they have a finite amount. I'm assuming that they do. I don't
Yeah.
think that it's like sharks where they just They're like, surprise, here's another one.
That's just really, really crazy.
I
didn't know
I
that.
think it would take a lot of force to like break something like that.
Yeah.
But yeah, they have extra just in case.
That's so cool.
Super cool. So let's start off with rattlesnakes. Rattlesnakes are like probably the most widely recognized species, especially here in Texas.
Yeah.
Right. So we have about 10 species that are native here.
I don't think I knew that.
Yeah, we got a lot.
It's like, to me, rattlesnakes were like cats, where you're like, that's a cat. That's
that
a
one's
cat.
orange.
Yes.
That one's black.
That's a mean cat. And then
That one's got long hair.
Yeah. And then rattlesnakes, it's like,
Is a rattlesnake.
I've seen them up close, but I've never taken the time to see if they look different.
Yeah. And some of them really, really do. So, but 10 species in total, right? They're the most common. They're the most widespread. Like I said, personally, I think they're probably the most easily recognized by somebody that maybe has never seen a rattlesnake before ever in their life.
Yeah.
You know what I mean? Like if you know kind of in the back of your head, just a generalized description of a rattlesnake and you see one, you're like, that is definitely a rattlesnake.
Yeah.
So they have the buzzing rattle is the most easily identified feature, right? And it's specific to these species. And it's actually really, really cool. So the rattle is actually made of hollow buttons. The technical term is buttons. And they're made out of a protein called keratin, which makes up most of the scales, for the snakes, and also our fingernails and our hair. So the buttons are actually hollow, and they're really loosely connected. So when the rattlesnake goes to wiggle its tail, all of the buttons bang together, and then they make that buzzing noise.
So they move their tail like super fast.
Super fast.
That's so cool.
Yeah. So like, and I've seen just rattles, and there's no way, because I've tried. I have a rattle. Like even if I do, like I shake my hand really, really fast. Like I can't even get close to reproducing that noise. Like it's just a really fast, like really fast click. But yeah, so you can imagine how fast they have to move their tails in order to make that noise.
Yeah.
Wild.
So cool.
So let's talk about what happens when you get bitten by a rattlesnake.
Scary.
Yeah. Which it does happen, right? It's not super, super ultra common, but it does happen. Mostly their venom is made up of a hemotoxin, which, and sometimes some neurotoxins, it does depend on the species, but mostly hemotoxin, which is the stuff that breaks down your tissues and your blood cells and things like that.
Yeah.
So that's the worst thing that happens to you when you get bitten by a rattlesnake, is that a lot of your integumentary system, your skin, your blood cells, things like that, just starts to break down.
Ugh. Like jelly?
I don't know if it's
I've never seen. I've seen rattlesnake bites where they get really swollen.
Yeah.
But I've never
Actually, I don't think I've ever Googled it. I don't know that I want to Google it.
Yeah, maybe don't do that.
Maybe don't do that.
It's kind of gross.
It's probably not something you should do at home.
But it is very cool to think about.
Yeah, and most of these animals are using this venom to hunt with. So unfortunately, when it does happen, it's just kind of an unfortunate byproduct of something that has adapted and evolved over years to specifically hunt prey.
Yeah.
And I think that's a huge misconception about really all snakes in general, is like they're not out to get you. Like that venom has developed for them to hunt prey. Hence, you are way too big for a rattlesnake to eat, and they don't really want to waste that on you, right? Like, I mean, even some of our biggest species, like our western diamondbacks, can get several feet, 5, 6, 8 feet long, right? They're big kids. Still, even at that size, they're not going to be able to eat you.
Yeah.
And so that rattle really is not only a key to recognizing a rattlesnake, but that animal letting you know that it's there.
Yeah.
Right?
Just back up.
Exactly. That's why it's adapted. That's what the adaptation was for, is to let other bigger animals know, because most of these animals are native to like plains regions where we have large roaming mammals like bison and deer and pronghorn and things like that are roaming these areas, and they just don't want to get stepped on.
Yeah.
They're just like, hey, I'm here, I'm existing. Please don't step on me. Another big misconception I want to talk about is the myth that like baby rattlesnakes are more dangerous than the adult counterparts. For baby rattlesnakes in particular, like their venom, like dose per dose, is maybe just a little bit more toxic at best, right? Like their venom really isn't any different than the adult counterparts.
Yeah.
Babies are just a little bit more defensive because they're smaller. And that's probably where that myth, is perpetuated from, is that they're probably just a little strikier, a little spicier.
Yeah.
And that's just because they're babies.
They're so little.
They don't
and
know.
They're on the menu for so many other things.
Just a baby.
Just a baby. But I think the part of that myth that I had heard was that the babies couldn't control the amount of venom that they were like more likely to just completely give, what all that they had in that moment, which is maybe true for even, an adult rattlesnake. But that was what I had heard, like when I was growing up, is that the little ones couldn't mediate. Like they were just going to strike, give it all, and go. Right. So, yeah. I mean, regardless if that's, also not true, that was how I had heard that.
Yeah. Best thing that you can do in a situation like that is you hear a rattlesnake, stay away from the rattlesnake. But if you're lucky, from some of the statistics that I've done some research on, about 25 to 35% of the time, it's going to be a dry bite.
Yeah.
So they're just striking to like scare you off.
No
and
venom.
They're not. Yeah. They're not going to envenomate.
Do they choose? Because they have to flex that muscle, but do they choose when that muscle is flexed? Does that, you know what I mean?
Yeah. And I think that there probably is a neurological pathway that happens when they are envenomating, right? Because most likely if it's a dry bite, it's just like a little nip, they're probably not fully biting down, compressing that muscle. They're probably just like a quick little strike that they're like, please go away.
Yeah.
Like, please leave me alone, versus an actual hit and hence, compressing that venom duct and squeezing venom out. So, but moving on into another species that is unfortunately probably a little bit harder to spot are going to be things like copperheads.
Okay.
Right. Copperheads in particular have really cool, distinctive patterns that help them camouflage. Because again, most snakes, especially here in Texas, are terrestrial. They're hanging down on the ground. And copperheads in particular are going to hang out usually in areas where they can hide really well. And they have that really distinctive, like rusty brown, reddish color.
Yes.
And then those markings that go all the way down their backs. The easiest way to identify them is by those markings. And they're kind of hourglass shaped, right? So like if you're thinking about it and you're looking down on the back of a copperhead, the bands in the middle, they're going to be really skinny across the central part of the back. And then as they kind of move towards the belly, they're going to get wider.
Cool.
And so they come in like a variety of colors, as you can imagine, right? That kind of reddish, rusty brown to orange. But that's going to be the main identifier when you're looking at a copperhead. If you ever do come across an animal that has those hourglass shaped markings, you have an idea that that's most likely a venomous animal that you should stay away from, right?
Right.
So, but the really cool thing about copperheads is that similar to many rattlesnake species, they do also have the hemotoxic venom. But copperheads in particular, the hemotoxic venom has been used to study how to potentially cure things like breast cancer.
Wow.
Yeah, because the hemotoxic venom, it's not particular to cells that it destroys.
Okay.
So there has been some forward movement in studying how potentially using that hemotoxic venom could destroy cancer cells.
If you target those cells specifically.
Exactly.
That's cool.
Yeah. I mean, despite being, big and scary and having bad reputations, most of these animals, not only do they have very specific ecological niches that they occupy in their, ranges and their food webs and their ecosystems, it's just really, really cool how we can utilize some of these venoms for the future.
Yeah. That's super cool.
Yeah. So next one I want to talk about is cottonmouths. So these are known as water moccasins. They are our only semi-aquatic venomous snake species.
Yes.
Here in Texas, anyways. Coloration for these guys is pretty wide. It's pretty variable. For the most part, they're dark as adults. Juveniles can tend to be a little bit lighter brown color, kind of have darker band patterns down their backs. But adults are mostly dark brown, almost totally black.
Got it.
Their major identifier is the insides of their mouths, right? Hence, cottonmouth.
Yeah.
So what they do when they're in a defensive position is that they'll coil up really tightly and then they'll open their mouth. And that's the way that they're letting you know that they're a venomous animal, not to be messed with.
Yeah.
right? So like that's their defense system is like, please don't come and mess with me.
Yeah.
It's a bad idea for you and for everyone involved. And very similar to the other species we mentioned, they're the selenoglyphus, right? Things swing out because they're also pit vipers, and they also have a hemotoxic venom.
Sick.
Yeah, wild. Okay, so I want to talk about coral snakes.
Coral snakes.
So I want to talk about fang structure for coral snakes because it's different than our pit vipers. Our coral snakes are proteroglyphous.
Okay.
So what that means is that similar to our pit vipers, they have the same structure, right? The venom gland, the venom duct, the fang, the little hollow fang, right? Because that's where the venom is injected through. But for these guys, their fangs are fixed. So they don't hinge. They don't swing in and out as the animal opens their mouth. They're always in one place. So the crazy thing about our coral snakes here is that they're elapids. So they're closely related to things like cobras.
That's cool.
Yeah. So they're Texas cobras, essentially.
Yeah.
Right. So
sick.
Again, like probably the most venomous animal that we have here in Texas. Right. Because their venom is hemotoxic and does have neurotoxins. So that's the kind that not only breaks down your body systems, but like
shuts down your nervous system.
Yeah. Stops your brain from working.
Crazy.
Yes. So, but they're apostomatic, which means that their defensive adaptation is their bright color, right? Because the red and yellow killifellow, red and black friend of Jack is in reference to milk snakes who copy a similar color pattern, but that's their adaptation to let you know that they're venomous. It's just like the big, bright, bold color.
Warning colors.
Exactly. Warning colors. Don't touch me.
Don't look at, get away.
Yeah, don't even look at me.
I'm cute. But
they really are. They've got like these adorable little tiny heads, and that's when the idea of like identifying a venomous snake by the shape of its head or its pupils comes into play.
Yeah.
Because they got teeny tiny little heads. They're adorable. But like, other than not knowing, that they have the warning colors, the very clear color pattern, itty bitty little head. You don't know.
So little. And do coral snakes also have black eyes like the milk snake? Do you know?
As far as I'm aware, yeah. So like they're really dark.
Yeah, like you can't see their eyes really.
Yeah.
Like unless you're really close to them to see the pupil, it's just like, but it's all the same color.
Right.
And so there's no cat's eye. It's just like all black.
Yeah. So you'd have to try really hard
Yeah.
to see what the pupil looks like.
Right.
For sure. So, but because they are proteroglyphous with their fangs fixed in an upright position, the fangs are smaller, right, to begin with. And so these animals are much smaller than several of our other venomous snake species, like our western diamondback rattlesnakes. So smaller snake, smaller fangs. They've got smaller mouths than most of our other venomous snakes and our other pit vipers. And they're also incredibly shy. They
so shy.
Do not want to be messed with. About 50% of the time, if you unfortunately encounter a coral snake and you get bit, 50% of the time it's a dry bite.
Wow.
They just don't want to be messed with. Like that's it. They also, I've found this really funny. They have a defensive system where scientists theorize that it's an adaptation to warn off larger animals, but they make little popping noises.
Really?
They're emitting air from their cloaca, which for snake species is the entrance and exit of all things, the end of their body system.
Yeah.
But essentially it's like little coral snake farts, and they're just trying to make a noise to get you to leave them alone. All of these species are incredibly important to the ecosystems that they belong to, right? A lot of them actually help with things like pollination, like spreading seeds, right? Because if they are, a diamondback rattlesnake is eating a squirrel, and then that squirrel has eaten whatever, seeds, nuts, berries, that sort of thing. If that animal digests, right, and the rattlesnake digests the squirrel and leaves its remains, elsewhere, like they're spreading.
They're like dropping seed bombs in the form of squirrel corpses.
Yeah, a little bit. But yeah, I mean, they're essentially they're spreading the seeds of a lot of these plants.
Yeah.
And then the biggest thing is that they also control populations of small vertebrate species, right? So they're directly affecting a lot of the growth of these ecosystems, as well as cross-pollination and, essentially the makeup a lot of their ecoregions that they belong to. So the takeaway here is snakes are super cool. Most of them have defensive adaptations to let you know that they are there and to not mess with them. And also, if you see a snake in a wild place, just leave it alone.
We would like to thank Texas A&M Kingsville and the National Natural Toxins Research Center for sponsoring this episode on snakes.
Yeah, so we, in our next episode, actually, we have a companion episode, and we had the opportunity to go down to Texas A&M Kingsville and the National Natural Toxin Research Center and do an interview with Dr. Elda Sanchez, who's the director of the program. And we got to learn some really incredible things about snakes and about how important Toxin Research Center is and how important their research is and what they're doing. And we got to visit their facility that actually houses a lot of venomous snakes. We got to see some really, really cool things.
So make sure you check out the companion episode and listen to our interview with Dr. Elda Sanchez.
Thanks for listening today. We hope you're enjoying our deep dive into the fascinating world of poison. Visit wittemuseum.org/podcast to subscribe to Wonder with the Witty so you don't miss upcoming episodes. And please rate and review the podcast to help others find it. Music in this episode by Randy Granger. Check out more of his music at randygranger.net. That's all for this episode. See you next time.